Hi, my name is Anthony DiMauro. I'm here today to talk to you guys about how fluid mechanics are applied in everyday lives. Well, so summertime, it's hot out. What do we all like to do? We like to go swimming, right? Cool yourself off, you enjoy yourself, get a little nice tan, and it's all a good time. Now, when I was younger, as a little kid, I had a little sister. And what we do in the pool is we played volleyball, right? And you have the ball, and I would do this trick. I grab the ball, put it underwater, and for some reason, it shoot right back up. Now, what kind of assumptions can you make when this happens when you're 12 years old? First thing comes into mind is, it's gotta be magic. That was definitely the first thing I told my sister, and she thought it was probably the coolest thing ever. Now, after many years of going to school, specifically fluid mechanics, I learned one thing. Clearly, it's not magic. It's actually this one thing called buoyancy force. Now, before I get into how buoyancy force affects the ball, let me just show you this diagram that I came up with. So, you have your pool, you have the ball applied in the pool, and it's floating. Now, as you can see, you have the weight of the ball pulling it down, as well as the force of my hands pushing it down. Now, what's reacting? It's this thing called buoyancy force pushing it right back up. Now, what is this thing? Here we go. Buoyancy force. An upward force exerted by a fluid that opposes the weight of an immersed object. So, in real English, this is what it really is. You have your pool, right? And you have your water. You have your ball, right? Big, nice ball. With the weight of the ball pulling it down. We give that as our WD. Now this buoyancy force, to make it float, is actually pushing it right back up like this. So what is buoyancy force? How do you find this out? That's the equation right there. It's force B equals specific weight of the fluid times the volume displaced of the fluid. Now, as you imagine, this volleyball would float on top of the water. How is that possible? How is that relative to this buoyancy force? That's when the weight of the ball is actually equal to the buoyancy force. That means the amount of force, pounds, ounces, that this weight is pulling the ball down is equivalent to the force pushing it right back up from the fluid. So, from here, I can show you two diagrams explaining a little more clearly than this. As you can see, for it to be in equilibrium or floating, the weight is equivalent to the buoyancy force. However, let's say it's a bowling ball or it's a rock. How come it goes straight down? Well, that's because the weight is greater than the buoyancy force, meaning this ball right here would be on the bottom because the weight of this rock or bowling ball is greater than the buoyancy force. It's actually quite simple. Now, another thing what would happen when I was younger is I'd always try to grab the volleyball and swim to the bottom of the pool and try to touch the bottom. Now, I know I'm not the strongest guy, but this was actually very hard for some reason as I was younger. How come it was this hard? Well, that's because as you go down, the force of the ball, I'll draw it right here, the force of the ball that you're pushing down between the weight and you're applying, force of my hands plus the weight of the ball, there's a reactive force pushing it right back up, the buoyancy force, like this. So as you're going down, you feel the exact exertion right back up on top of you. Now, if, let's say, you are strong enough and you make it to the bottom, that's because these two forces added together is greater than the value of the buoyancy force. You understand? Now, to give you a good example of how this is applied, I found a video for you guys, cool YouTube link, that uses a cork as opposed to a ball. This is just a quick. So, as you can see on the screen, there's a cork inside the water. Let me just turn this volume up so you guys can hear me talk. So, in order for it to float inside the water, basically, the weight of the cork pushing down, which is obviously minuscule, is equivalent to the buoyancy force pushing right back up. As you can see, this weird hand-looking thing is pushing it down and it floats right back up.
However, wait for it. Now, you see this idea of him pushing his hand down and keeping it there? That's because the force that he's pushing it down, is greater than the buoyancy force pushing it right back up. You guys understand? So, we finished with this application. And now, let's try to find my PowerPoint again. So in conclusion, clearly it's not magic, it's fluid mechanics. Now I know this was a funny, simple explanation as to how buoyancy force works, but it's actually applied to real, more important things such as boats. So let me just show you a quick diagram of how boats are affected by this. Because the last thing you want is to be on a cruise ship and you're slowly but surely falling down and sinking into water. So you have your ocean, and you have this gorgeous Titanic yacht floating along, right? Now same application as the ball, you have the weight pulling it down, weight of the boat. However, the buoyancy force is pushing it right back up, allowing it to float and allowing it to travel. So, basically, the moral of the story is there's no magic happening in water. There's no mystery as to why this occurred. It's buoyancy force. And that is how fluid mechanics are applied to our everyday lives. Any questions? Awesome. Thank you.